Hello. So we're going to do even more examples just to try to help you get good at this. And it's going to be evaluating trig functions using our clues that we have here. So let me come up with a couple. So let's say we're going to do tangent of, we'll do 5 pi over 4. Um, and let's just give it a whirl. So again, the steps for this are you have to figure out what quadrant it's in to get the sign, SIGN, and then we're going to get the value right after that. So when I'm looking at this, I will label this 0. I will label this 4 pi over 4. And again, I'm doing that because of the denominators telling me how to count. And if I were to swirl even more, this would be 8 pi over 4. So we're always going off of this horizontal. So here's 4 pi over 4, which means 5 pi over 4 would be one more increment this way. And so I am in quadrant 3, which means tangent will be positive. Now I need to get the value. So all I will do is I will look in my tangent row for what my value would be. Oh, it's going to be 1. And so that is my answer. All right. How about cosine of 7 pi over, should we do 3? Oh, this one is interesting. Yeah, let's do it. All right. So if we're doing the cosine of 7 pi over 3, here we have 0. I'm going to label my axes appropriately. I'm counting in increments of 3. So this is 3 pi over 3, which means this guy will be 2 pi or 6 pi over 3. So what quadrant is cosine of 7 pi over 3 in? Oh, so he's more than 360. So he's going to loop and then he's going to come land back in quadrant 1. So cosine is positive. I'm looking at the cosine row and I'm counting by increments of pi over 3. So my answer is 1/2. Last but not least, we'll do an interesting one. 2 sine of, or 2 sine squared of 5 pi over 6 minus cosine of, let's see, 4 pi over 3. All right, so let's see how we can do this. So first off, when you see the squared there, all that means is get the sine of 5 pi over 6 and then square it, okay? They just, for some reason, mathematicians don't like putting those parentheses in, so they just move the squared. So I have to evaluate the sine of 5 pi over 6. So the first thing I need to do is figure out what quadrant it's in. I'm going to come up here, I'm going to erase these. And now I'm counting in increments of pi over 6. So this would be 6 pi over 6. All right, so 5 pi over 6 is in quadrant 2, meaning sine of pi over 6 is positive. Now I just have to get the value. So I'll go to the sine row, pick up my increment, pi over 6, so the answer is 1/2. And then I've got to square this. All right, minus cosine of 4 pi over 3. So I am now counting in increments of pi over 3. So this is 0, 3 pi over 3, and then this would be 2 pi or 6 pi over 3. So 4 pi over 3 lands here. All right, it is in quadrant 3 where cosine is negative. Okay, so tangent's the only thing positive in quadrant 3. Now I need the value. Cosine of pi over 3 is, oh, 1/2. Beautiful. So now I just have to do out the math. 2 times 1/2 squared is 1/4 plus 1/2. So I'm ending up with 1/2 plus 1/2, which is 1. Yay! All right, last but not least, like what would you do if you had something like this? Sine of 3 pi over 2. That guy does not land in this chart here. So can I not figure it out? Of course I can. When you have guys counting in increments of pi over 2, or if I gave you, say, like the tangent of pi, what we're going to be drawing our attention to is this graph. Okay, sine of 3 pi over 2 um, is -1. Tangent of pi, really what I need to know is the sine of pi, and I need to know the cosine of pi, right? The sine of pi is 0. Cosine of pi is -1, so my answer here is 0. My other options for if you're counting by the pi over 2's is you can look at the unit circle and use the x is cosine, y is sine type situation. But that's it.